Okay, so here we are, 5.4. We've talked about polynomials all chapter. We've talked about what a polynomial looks like terms, how we can group like terms and gather them together. We talked about adding polynomials, right, where we have a polynomial in the brackets, and then there's a big plus sign and another polynomial in the brackets. How do we manage that? That one was pretty easy, right? Adding polynomials is pretty easy. You just drop the brackets and you group the like terms and you add the coefficients, the numbers in front, you add those together, and then you're pretty much done. So we did that last lesson. Today is subtracting polynomials. Now listen very, very carefully. This is going to look hard, but it's not hard, okay? This is going to look like it's a little complicated, but it's very much the same as adding polynomials. There's only one little wrinkle. There's only one little extra thing that you have to do, okay? And I'll get to that real soon, but there's only one little difference, so don't worry. All right, subtracting. Okay, so remember we talked about the word opposite from this year, right? And you've heard of that word opposite. When we talk about opposite numbers, what we're talking about is what? Anyone remember? You want to explain to me what an opposite number is? So if I give you the number 5, what's the opposite number? Okay, good. I heard two prominent answers. You said -5 right away, which is correct. And you said the number that you add to it to make 0, which is excellent, okay? Those are excellent explanations. So the opposite number would be, in its simplest form, it's the same number, but the opposite sign, right? So that's the opposite part, the opposite sign. So it's either a positive or a negative. And the meaning of opposite, the definition of an opposite, is the number that you add to get 0. So we did the with the algebra tiles, right? We have like a big square, an x squared tile that's clear, that's not filled in, and then we have like a dark one, and those are opposite, and so they combine together to make 0 pair. So excellent. So what's the opposite of 2.4 then? That number would be -2.4, right? The opposite of 2.4. Because this is understood to be a positive number, positive 2.4. Hopefully you guys can see that up there. And so if it's a positive 2.4, the opposite is negative. Good. Okay, what's the opposite of -10? Positive 10, okay? Now, you don't always have to put the plus sign in front of just a standalone positive number. You can just write 10, but I'm going to write the little positive sign just to be clear of what we're talking about. So one is positive, one is negative always. All right. By definition, opposite numbers have a sum of, what did we say? 0. Okay, so when we add opposite numbers, we get 0. The same idea applies to polynomials. Opposite polynomials have a sum of 0. Opposite. DD. Oh, you're the best. Yes, okay. So what is the opposite of 2x? It is, shout it out. It's pretty early in the morning. I know. I hear some, this is what I hear. That's all I hear. It's like a combination of, some sort of like, just kind of like mumbling. So I know that most of you probably know the right answer. So the opposite of 2 would be what? -2. So the opposite of 2x would be -2x, right? So think about the tiles, right? Here's 2x. You don't have to draw this, but I'm going to draw this. So if I were to add these two that are filled in, that would give me 0, wouldn't it? They would cancel each other out. So the opposite of positive 2x is -2x. Positive 2x right here, -2x right here. Okay? All right, what's the opposite of -x squared? Yeah, that's going to be positive x squared. Okay, awesome. Positive x squared. And that negative, if it doesn't have a number in front, that's understood to be a 1, right? So a negative x squared is -1 x squared. So that would be a positive 1 x squared is the exact opposite. All right? Okay, what is the opposite of each monomial listed below? Let's go through these pretty quick. That's going to be positive 5x. Positive 11 is going to be -11. And -24x to the 4th is going to be positive 24 x to the fourth. So you don't change the variable part at all. You don't change that. You just change the sign on the number in front. Okay? All right, so let's move from monomials to binomials. How do you think you'll get the opposite of a binomial or a trinomial for that matter? So if we know how to get the opposite of one single term, how do I get the opposite of two terms? What do you think? You change the sign on both terms at the same time. Excellent. So the opposite of this would be negative 2x minus 3. Notice I've changed the understood to be positive sign there, and I've changed this plus sign to a minus. Excellent. And if we were to add those, 2x minus 2x is 0. 3 minus 3 is 0. So we have just 0, and that's perfect, right? Just 0. Okay. So for the trinomial then, the opposite trinomial to what's shown here would be negative 4x squared. Would it be plus 7x here next, you think? Mm-hmm. Yeah, plus 7x. And then minus 3. I like it. I like it. Everybody agree? Okay, pretty easy so far, right? And this is a very huge part of subtracting. So you must get the opposite of every term in the polynomial. The opposite of every term we're going to put in there, if you can fit it in there. Every term. Okay, any questions so far about opposites? Pretty easy, right? Okay, let me tell you how the opposites factor into subtracting. So, when subtracting polynomials, it's the same as adding the opposite of every term in the second polynomial. So the word that goes in here is opposite. When subtracting polynomials, it's the same as adding the opposite of every term in the second polynomial. Then you combine those terms to simplify like we did last couple sections, okay? So the one change is you're going to see a subtraction here instead of an addition. Last section we did addition. Now we're doing subtraction. So the first step and the only difference, and this is the nice thing about math, honestly, and especially in high school, we go one class leads into the next, leads into the next. So you know how to add polynomials, and usually what we try and do is add one more thing, sorry about the pun, add, but we show you one more thing to add on to what you learned how to do the other day. So we know how to add polynomials. So the one little extra thing is to switch the second polynomial over to all of its opposites and then add that, because that's the same as subtracting. Okay, so it's just one little extra thing. All right, so I can remove the brackets on the first polynomial. It doesn't change at all. Okay, so I probably will do that now. You can keep the brackets this first step if you want. But what I'm going to do now is I'm going to change this subtraction to an addition. And what am I going to add? But I'm going to add all the opposites from the second polynomial. So this is like adding a negative 7x squared minus 3x plus 2. Okay? And again, you could keep the brackets here this first step if you like that better. So that is exactly what we saw last lesson. Exactly the same thing. And from here on, now it's the same as yesterday. Same as last lesson. So I'm going to remove the brackets because it's addition now. So I don't need to keep the brackets. I'm going to go 3x squared minus 6x plus 4. And I'm going to drop the brackets here. Now remember what we do if we have a plus minus like this? If we add a negative, that's the same as... Yeah, it's the same as subtracting. So we're going to subtract 7x squared. So when I drop those brackets, you can combine these two signs into one. And then keep writing the rest, minus 3x plus 2. Okay. All right. Now, last lesson, I encouraged you to rewrite this, to shuffle things around so that you have like terms together. I think at this point, if you don't want to do that, you don't have to, because I have full confidence in you that you will be able to spot the like terms wherever they may sit now in this long list right, in this long polynomial. So what I mean by that is you're going to look for all the x squared terms wherever they may be, and you can just kind of do something like this and indicate that you've spotted the x squared terms, and then write your combination of those two. So 3 minus 7 is going to be what? It's going to be negative 4x squareds. Yeah. And then what I would do is like literally stroke them off kind of like that so that they're out of the way for you now. All right. Let's focus on the x terms now. Here's an x term, and here's an x term. So negative 6x minus 3x combines to? Very good, negative 9x. And again, you want to practice this mental math, okay? Adding integers and subtracting integers, very important. You need to know how to do that. Okay, so these are gone. That's good. We'll get rid of those. And finally, just our constants left over. 4 plus 2 is plus 6. Okay, I think I'm just going to double check my work, which you should always double check your work a little bit, even if you're super confident. Just double check that you got everything and didn't miss anything. Okay, there we go. And then please circle your answers. It's important in my class that you show your work and circle your answers, okay? And I will be bugging you from now until you graduate about that. So you may as well get practiced on it right now. Show your work just like this. Circle your answers just like this, okay? Because it's important for me to know, I'll tell you why that is. It's important for me to know that you know exactly what your final answer is, okay? There's nothing more confusing and mysterious to see a whole page of work with no answer shown, and you have maybe 2 or 3 possible answers on this page. To me, that's this student doesn't know what he's doing or she's doing. Like, it's just like a bunch of random jumble. There's no way I can give you full marks. Even if I do spot the right answer somewhere on the page, you're not going to get full marks. So you got to show me that you can do your work, and then show me that, hey, this is my final answer, and you have to declare that, okay? Because that's how you get full marks, okay? So you know what you're doing, and I can see you know what you're doing. All right? Again, just giving you some info, tips for success here. Okay, I'm going to give you a minute. I want you to do B if you haven't done this already. Some of you are already jumping ahead. That's great. Do B on your own. All right? See if you can do B on your own and see if we get the same answers here. So here's B right here. And you can check back, obviously, to your other examples. I'll give you a minute to do that. Okay, so here's my answer for B. What I did was I changed this subtraction into an addition. And so I've kind of got all my work here, but I just dropped the brackets here. And then I added a negative a squared, so that's the minus a squared right there. And then I also added a positive 3a, so there's the positive 3a here. And then I added a negative 2, which turns into that minus 2. So when you gather all those like terms, you collect the a squared terms together, you collect the a terms together and the constants, and then you should be done. Any questions about that, or anything you want me to go over with that question right there? Is that good? No questions? You guys could do that on your own now? Okay, all right, well, let's see. The next one is subtract using algebra tiles. And again, we're going to add the opposite with algebra tiles as well. So let's just do this final question on this page. So with algebra tiles, same thing holds true. We're going to add the opposite. So you're going to change the little minus sign to a plus sign. And then if you have a white big square x squared tile, you're going to change it into a black big x squared tile, and so on. You're going to flip the colors of all of them. So this looks like this. Let's draw this on your paper. So I'm going to leave these the same. And I'm going to change this to a plus, and I'm going to add a negative x squared tile. I'm going to add a positive x, and a positive x, a positive x, and a positive x, and then a negative one unit tile. So when I collect these, and let's see, do I have, okay, so the x squared terms, I have 3 negatives, so I have negative 3x squared looks like. I have 1, 2, 3, 4, 5 x's. And then one of these ones and one of these negative ones, they cancel out. So I just have plus 1 left over, and I think that looks pretty good to me. How does that look to you? Yeah? Okay, thumbs up, nodding the head, anybody? Yeah? Okay, you guys aren't giving me much feedback here. Is that because it's too easy? Is this too easy? Or is it like so hard you don't even know what to do? Okay, give me a sign. 5 is 5 out of 5. This is really easy, Mr. Maxwell. 0 is, I just have not been listening the last 20 minutes. I don't know anything. Where are you? Okay, scanning. Okay, I'm seeing a lot of fingers. That's good. Okay, that helps me. All right, this is easy. Good. Let's keep going. Next page. So remember how we added horizontally and added vertically? So let's subtract vertically. Let's see what that looks like. And believe it or not, this skill is going to come in very handy as you move into grade 10 for sure. I'm thinking of your grade 10 math. We are going to be solving systems of linear equations, and you're going to have to add polynomials vertically. That's going to be one of the things that you're going to have to do then for sure. So you're going to have to know how to do this. Let's learn now. All right. So I'll rewrite, I guess. I'll rewrite this first one. Remember, we don't change the first one at all. We don't change the first polynomial at all. It's just the second one. So I'm going to change this to an add, and then I'm going to change the sign of all of these and put them underneath. And where I put them underneath, remember, keep the like terms in the same column, okay? So if there's an x squared term, which there is, I'm going to change the sign, and I'm going to put it underneath the 3x squared term, okay? And I'll just put this little plus off to the side so we can know we're remembering that we're adding. Okay, and then this is going to be a plus 3x. So plus 3x goes under here. And then plus 2. So just once again, I've got the x squareds on top of each other. Great. I've got the x terms on top of each other. Awesome. And then I've got the constant terms on top of each other too. So that follows. So 3 minus 2 is 1. So that's just a regular old x squared there. 3 minus 2. Okay. 4 plus 3 is going to be plus 7x. Okay. Now remember, with the x's, you just keep them as x's. An x plus an x is not an x squared. Just please make sure you don't do that. Okay, I've seen students do that. Oh, we got an x and an x, that's 2 x's, so it's x squared. No, you leave that variable alone exactly the way it is. Okay, and then negative 1 plus 2 is a plus 1. Thank you. You're the best. Well, he's the best. All right. Okay. So does that look good? Are you guys okay with that answer? All right. Okay. Here's the second one over here on the right. I tell you what, why don't you do that one on your own? Please show your work just like I showed my work. Okay. And I already have seen that some of you are not showing your work much. So I want you to get into a habit of doing just what I did. You don't have to color code it, but please write it vertically. Make sure everything's in line. Show your answer, and I will circle my answer here too. That's the one last thing that I should do. Okay, so go ahead, take a minute, do that second one, please. Okay, so I got them all in columns. I've changed it to addition. 5 minus 8 is going to be negative 3x squareds. Negative 3xy plus 7xy. Those are like terms, so I'll just focus on negative 3 plus 7. It's going to be plus, what? 4xy's. Good, very good. And then 2 and 4 together combine to make 6, and those are 6y squareds. All right, so you want to double check your work there, and I think I'm happy with that one. Anybody get that one? Get that? Awesome. Okay, good. Lots of hands in the air. All right. Well, you guys are awesome. You guys are awesome. So we're kind of getting to the end of the lesson here. There's not much more other than just to do a bunch of practice, and then I'll give you your textbook assignment. So let's do a bunch of practice here. I'll do a few together. So if I'm doing 9 minus negative 7, I'm going to change that to 9 plus 7, guys, right? I'm going to add the opposite. So 9 plus 7 is going to be, what was that, 16? Awesome. So this one's going to be a negative 9. I'm going to change that to a plus and change this to a plus. So that's like plus plus 3, which is just plus 3. Okay. What's negative 9 plus 3? Negative 6. Okay. So negative 9 minus 5 is the same as negative 9 plus. Now, minus 5. So I'm going to do plus negative 5, technically. So you don't, you might think, well, why do I have to rewrite that? You don't really have to rewrite that. You don't. Polynomials, you're going to want to rewrite the polynomials probably just so you can make sure you account for all of the signs. But like -9 minus 5, you could probably do that in your head. But this is how you would do it following all the rules. Change it to a plus and then change this 5 to a -5. So you see how that's the same? -9 plus a -5 or -9 minus 5 is -14. I think I do need to take a little drink right now. My throat's starting to get after me. So -4 minus a -8, that turns into a plus +8, doesn't it? -4 plus +8. So -4 plus 8 is +4. And I think there's another one on the row. So I'll tell you what, I'm going to skip down to B. I'm going to skip down to B and number 2. And then I'm going to do a couple with you, maybe 1 or 2, and then I'll get you to do the rest, okay? So this one here, again, I would rewrite things over here. You could probably change your signs on your paper here, but I don't know. -9x minus 7. So 13 minus 9 is going to be 4x's. And then 4 minus 7, that's going to take us into the negative category. That's going to be -3. So that should be 4x minus 3. So I'll do the last one here. So with this one, what do you notice is different about this one? What's different about this one than the rest? Go ahead. Was that hand up? No.
They're not lined up. 8x is not lined up.
They're not lined up properly as far as like terms go. Yeah. So you're going to want to do that, okay? So 2x squared minus 9x minus 3. And then I'm going to change this. I'm going to do two things at once. This is going to become a plus. And then I'm going to add the opposites of what I see down here. So I'm going to write the 3x squared first, but that's going to be opposite. So minus 3x squared. And then in this column, I should have the x term, which is where, over here, I'm going to make sure I write the opposite of this. So it's going to be plus 8x. Are you guys okay if I do those two steps at once? Are you following me? I'm rearranging them and changing the signs. I think you guys can get this. So 14 is going to be in the last spot here, and I have to change that to a -14. Okay? Okay. So I add these up. 2 minus 3 is -1, or just -x squared. -9 plus 8, that's going to be minus 1x, or just minus x. Again, we won't put the 1s there for coefficients. And -3 minus 14, that goes further into the negative territory to -17. And then you circle that answer, and that's how that goes. All right. I'm going to show you one more example. I'm not sure if you're going to run into this, but it is it's missing in this lesson. So I don't know, in your textbook you might not run into something like this, but I think we've done this before with the adding, so it might show up with subtraction. So please put a J here for me, okay? We're going to do J, one more. Just put that on your sheet somewhere, wherever you can maybe fit that. And what happens if, let's do something like this, 2x squared plus 5x minus 1. And I am going to be subtracting a 3x to the power of 3 minus 5x squared. So some of the terms don't have a like term partner in there, okay? So we've done this with the addition, but with subtraction, you have to remember what we do there. So I'm going to rewrite that vertically and show you visually here what's going on. And this x cubed does not have a partner. It doesn't have a column here so far. So what I'm going to do is I'm going to put the x cubed in its own column outside of these three columns that I have set up right now. So I'm going to change this to a minus, whoops, I got to go further over, minus 3x cubed. You see, so it's got its own column over here because there's no other x cubed term to the power of 3 in the first one. So I would just say you have to be careful vertically. If you have unlike terms underneath each other, you're going to be tempted to add them up. So they should have their own column. All right, so I'm going to change the sign here and put the 5x squared underneath this 5x squared. And I don't have an x term over here, and I don't have a constant term over here. So I guess that's the way vertically you would probably leave that. Okay? And then you just add up vertically like you have. And if you don't have anything to add here, well, it's just like adding 0, I guess. So I'm going to have negative 3x cubed plus, so this is 2 plus 5 is 7x squared. And then I don't have anything to add to 5x, so I'll just drop that 5x down. I don't have anything to add to negative 1, so I'll just drop that minus 1 down. And that would be my answer there. Okay? So that's maybe a bit more of a challenging one. Does everyone see, though, how that would work? And horizontally, it's just as easy. If there's no partner, then you don't add it. So you don't add anything to it. So this one would be a minus 3x cubed. You just write that down, which we have here. The x squareds, you would combine together. So you add the opposite of negative 5x squared. So 2 plus 5 is 7x squared. The 5x doesn't have a partner. The negative 1 doesn't have a partner. So just write those down and leave them. Okay? So that's a little bit of a higher level one there, but that's what you do if they don't have any partner values. Okay. No questions? Everybody's good? Understanding? Okay. Okay, so go ahead and finish these questions on the worksheet, please. Finish those questions on the worksheet. I'll probably throw up some more answers. I'll throw up some more answers as we move on here, and then maybe by the end of the class here, I'll give you your homework assignment too from the textbook, okay? Okay, so go ahead and work on those questions A through I, and this E one as well, I guess. So again, here's some selected answers from your worksheet. Check your answers with those. The ones that I don't give you answers for, I'll get you to do on your own, and I'll check those later. Okay, here are your textbook questions today, class. You can write those down. They will be on the website as well. You can check that out, mrmathwell.com, on your Math 9 page. You will get, for this class, you will get tomorrow's class to work on this. So if you get started today, that's great. You should get a good start on it, and tomorrow you'll be allowed to finish this, okay? Also, there will be another worksheet to follow, which I believe is in your notes. So we'll work on this tomorrow as well as the textbook questions. Okay, just a reminder there, on number 2E is negative 9. I think I had a wrong answer there for number, or 1E. So it's a negative 9 there. Everyone just double check that. So any other questions before we officially close this 5.4 lesson? Any other questions about what you saw? All right.